Hi, I'm Rahul. Today I'm going to introduce Pythia. We observed three key shortcomings in prior prefetching works that significantly limits their performance improvement. First, they mainly use one program context information for prediction. Second, they lack system awareness. And third, they lack in-silicon customizability. Towards this, we introduced Pythia that can autonomously learn to prefetch using multiple program context information and system level feedback, and can be customized in silicon to change the program context information or the prefetching objective on the fly. Pythia formalizes prefetching as a reinforcement learning problem where the prefetcher itself acts as the RL agent and the processor and memory subsystem acts as the environment. For every new demand request, Pythia extracts a set of program features to take a prefetch action. For every prefetch action, Pythia receives a reward from the environment that evaluates the usefulness of the prefetch request under various system level feedback. We evaluate Pythia using a wide range of workloads and show that Pythia significantly outperforms multiple prior state-of-the-art prefetchers under a wide range of system configuration. We also show that we can easily customize Pythia using simple configuration registers for targeted workload suite to extract even higher performance than the basic configuration without using any hardware level changes. Finally, Pythia proposes a realistic and practical implementation of its RL algorithm that incurs a very modest area and power overhead over a desktop class processor. Pythia is open source and fully artifact evaluated. We welcome everyone to attend our talk in session 9B on October 21st. Thank you.